this section, we're going to talk about more with negative exponents. We're going to look at some more complicated problems. So in order to do this section, you do need to know how to add, subtract, and multiply signed numbers. You want to be able to understand and extend the addition property of equality for solving equations. And you want to be able to understand the rules of exponents, including the product rule, the power rule, and the products and quotients to powers rule. Previously, we looked at the quotient rule, which says b to the n over b to the m results in b to the n minus m. So division means subtract your exponents. Now, one of the things that I do want to point out is that we can also look at this from a different perspective. Instead of moving the m up to the top and subtracting it, we can move the n down to the bottom and subtract it, giving us 1 over b to the m minus n. The reason that we want to be comfortable with both directions is when working with negative exponent, the goal is always to write with positive exponents, which may not necessarily always be in the numerator. When working with exponents in this section, you can think of extending the concepts for solving equations. Recall when solving equations, when we move to the other side of the equation, we change the sign of the term. Here, when we move to the other side of the division bar, we change the sign of the exponent. The two rules above are the same but different in appearance. When deciding which form to use, always move the smaller exponent to the other side and subtract. Let's look at the following examples to get us started. This is just going to be some practice with our quotient and our product rules. So if we look at example A, we have x to the negative 9 times x to the 4. And the main thing we want to remember is, what did we do when we were multiplying things that had the same base? The answer is we want to add our exponents. And even though we have negative numbers here, we still have our same basic rules. So, in order to complete this problem, I want to add my exponents. I want to know what is negative 9 plus 4. Well, that's equal to x to the negative 5. Now, remember that we said our goal is to always write with positive exponents. And so for this problem, I still need to go ahead and make my exponent positive. In order to do that, I want to move it down to the denominator. So we get 1 over x to the 5th. And we're essentially done with this problem. Let's look at example B. Example B, in previous sections, we talked about the quotient rule. And according to the quotient rule, it said that we wanted to do x to the 4 minus 20. We always moved up our bottom exponent. And that still applies. If we go ahead and simplify this, then what we're going to end up with is x to the negative 16. And just like in example A, I don't want negative exponents, I want positive exponents. So I'm going to move it to the bottom, and I get 1 over x to the 16. This is kind of a longer method to get to the same answer. If you remember, I said that there were two ways that you could look at the quotient rule. You could either move the bottom exponent to the top, or you could move the top exponent down to the bottom. So when looking at this, we want to decide which one would be better. To determine which would be better, we want to look at which one is smaller. We always want to move the smaller exponent. Since 4 is smaller than 20, I want to do 20 minus 4. That means that I want to move my x to the 4th down to the bottom. If we do that, we get 1 over x to the 20 minus 4, which is equal to 1 over x to the 16th, giving me the same answer that I got previously. So that's one of the things you want to keep in mind when you're trying to decide which one do you want to move. So let's go ahead and try this on examples C and D. In example C, we've got two things we need to do here. The first thing is I want to simplify my numbers. We have 25 divided by 5 is 5. Where does it go? Hopefully we're okay with it going on top since 25 is larger. For our x's, which x term do I want to move? The 6 or the 8? Since 6 is smaller than 8, I'm going to move the 6. And so we get x to the 8 minus 6, or 5 over x squared. And you're done. For example D, again, same thing. We want to start by simplifying the numbers. 10 divided by negative 2 is negative 5. For my exponents, which one is smaller, 7 or 10? Since 7 is smaller, I'm going to move that one to the bottom, and we get y to the 10 minus 7, or negative 5 over y cubed. Now, should I move the negative 5 to the bottom? Because we said we want positives. The answer to that is no, because remember, we want positive exponents. Since negative 5 is not an exponent, it is a constant or a coefficient, this is not something you can move to the bottom and make positive. So our final answer is negative 5 over y cubed. When dealing with more challenging problems, remember order of operations. Start by simplifying inside the parentheses, if possible, before applying any outside exponents. If the outside exponent is negative, flip the entire fraction and change the outside exponent to a positive. In quotations, distribute the exponent. If you move to the other side of the division bar, change the sign of the exponent. And finally, combine like terms, in quotations, by adding or subtracting the exponents for each variable. So let's look at some that are just a little bit more complicated. So if we look at example E, the first thing that I want to do is I want to get rid of the parentheses. Note that I just have 5x cubed inside parentheses being squared. The square is not applying to the whole fraction. So the first thing that I need to do is get rid of my parentheses. I want to distribute the 2. Distribute in quotations. So if we square everything inside, we get 5 squared is 25 because it's a number. And then I want to remember that we want to multiply our exponents. So we get x to the 3 times 2 is 6. We still have our x to the 10th on the bottom. And then from here, we do want to go ahead and simplify. The number 25, since it has nothing to cancel with, we're just going to keep it, and it stays on the top. For our x's, we want to decide which one do I want to move. Do I want to do 6 minus 10, or do I want to do 10 minus 6? Since the 6 is smaller, I'm going to move it to the bottom. So we get x to the 10 minus 6 on the bottom. Simplifying this completely, we get 25 over x to the 4th. And we're done with that problem. Now, starting on example F, there's lots of ways to do this problem. So I'm going to show you 3 different methods just to emphasize the fact that it does not matter how you approach this problem. There's lots of things that you can do. As long as you're doing them mathematically correctly, then you're okay. So, method 1. The first thing that I'm going to do is we may want to distribute our negative 3. And that's a perfectly acceptable method. So if I distribute my negative 3, remember that we want to multiply each thing inside by negative 3. So if we do that, we get x to the negative 15 over x to the negative 6. From here, you may decide that you want to go ahead and take care of the negatives like we did in previous problems. That's fine too. So let's flip them around. We get x to the 6th over x to the 15th. I'm going to move my numerator to the denominator, make my exponent positive. And I'm going to move my denominator up to the numerator, make my exponent positive. From here, I want to, since 6 is smaller, I'm going to subtract it from the 15. And we get 1 over x to the 15 minus 6 is 9. Okay, so this is the first one. Method 2, and there's several different versions of this as well. Method 2, let's see what we can do. Method 2, I'm going to go ahead and flip the fraction. Since my outside exponent is negative, I can just flip the whole thing. And so if we do that, we get x squared over x to the 5th. Since we flipped it, I changed my outside exponent to a positive 3. From there, I can distribute the 3, and we get x to the 6th over x to the 15th. And we're back to where we were on the previous one. So from here, we subtract them, and we get x to the 9th. Okay, I'm going to show you one more, and keep in mind that there's lots of other ways to do this problem. Okay, so the last one, what I'm going to do is kind of what I mentioned in the previous slide. I am going to simplify inside the parentheses first. So if we simplify inside the parentheses, we are going to get x cubed. I do my 5 minus my 2 raised to the negative 3. Now I can use my power rule. We want to multiply our exponents, so we get x to the negative 9. And now I can flip this to the bottom, and we get 1 over x to the 9th. Me personally, I always like simplifying. Method 3 is my preferred method, only because I'm working with smaller numbers when I do my multiplication. And it always makes me a little bit more comfortable. I'm not having to multiply as much. And I usually end up with the correct answer. But again, it doesn't matter how you do this. You are going to have to, no matter what, we're going to have to subtract. we're going to have to multiply, we're going to have to flip. Those are the three things that must be done on this problem. Okay, for our next example, we're going to go ahead and practice our quotient rule a little bit more with negative exponents. So as I mentioned, one of the things we want to do is we're going to work with our numbers. We're going to start by simplifying the numbers. So 12 and 20. What number goes into 12 and 20? We should be able to divide both of them by 4. So if we simplify the numbers portion of this, we're going to divide by 4. 12 divided by 4 is 3, and 20 divided by 4 is 5. Now from here, there's several things that we can do with our variables. One of the things you may want to do is if you don't like negative exponents, let's move everything that has a negative exponent to the other side. But keep in mind, you can only move them if they have negative exponents at this stage. X cubed, it is not negative. I'm going to keep it where it is. X to the 7th, similarly, it is a positive exponent. I'm going to leave it where it is. Y to the negative 4, since it is negative, I'm going to move it to the other side and make it positive. And y to the 8th, since it is already positive, I'm going to leave it right where it is. For my z's, I can move both of them. I can flip them both around, so I get z to the 5th on the top, and I get z squared on the bottom. Okay, from here, we want to go ahead and simplify. So if they're on opposite sides, we're going to subtract. If they're on the same side, we add. So we still have our 3 over 5 for our numbers. For my x's, I want to do 7 minus 3, giving me x to the 4th. Since my larger exponent is on the bottom, my answer will be on the bottom. For my y's, note that I'm not dividing here, I'm actually multiplying. I did put that dot there. Since we are multiplying, we actually want to use the product rule, which means that I want to add my exponents. So we get 4 plus 8 is 12. And for my z's, we're going to subtract, and I want to do 5 minus 2 since 5 is larger. 5 minus 2 is 3. And we're done. Okay? Okay, so that works fine. Now, there's another way that you can do this if you're comfortable with negative numbers. Okay? So what we're going to do is, again, I'm going to start off with my 12 and 20. Divide them both by 4. I get 3 and 5. So for my x's, I do know that 7 is larger than 3. That one we're okay with. We can just do x to the 7 minus 3 is 4. For my y's, which one is smaller, negative 4 or 8? Well, hopefully you recognize negative 4 is smaller. Remember that I said when you move to the other side of the division bar, you change the sign of the exponent. So what we're going to do is y to the 8 minus negative 4, which is the same thing as plus a positive 4, which gives us y to the 12th. Okay, if we look at the z's, which one is smaller? Technically, negative 5, if we go back to when we talked about inequalities, negative 5 is less than negative 2. So I want to move my negative 5. So we get z to the negative 2 minus negative 5 minus negative 5 is the same thing as plus a positive 5. And so now if you do these computations in your head, that's fine too. We get 3z cubed over 5x to the 4th y to the 12th. And we're done with this one. So again, there's several ways to approach these problems. Let's look at one more example together that kind of is the epitome of what I would consider a difficult problem in this course. For this last problem, we want to talk about, okay, what's the best way to go about simplifying this? Now, we talked about how we can distribute the -3 to everything inside, but I will say that I don't consider that a good method for this one especially, because hopefully we should be able to do these without resorting to a calculator. And I certainly don't want to cube 32 or 24, let alone try to simplify a fraction with those numbers. So this is an example where I really want to follow order of operations, which is let's simplify inside the parentheses first. So if we simplify inside the parentheses, 32 and 24 are both divisible by 8, giving me 4 over 3. My x's, if I look at that next, I want to move my x squared down to the bottom so that I get 4 minus 2 becomes x squared. For my y's, -3 is smaller than +5. And if I do my computation, I'm going to do it off to the side. If we do 5 minus -3, that is the same thing as 5 plus 3, or 8. So simplifying inside, we get 4y to the 8th over 3x squared. And I have an exponent of -3 off to the side. From here, technically you could distribute, but remember that I like doing my negative exponent in 2 steps. Makes it a little easier to do the computations instead of trying to flip and cube at the same time. So the next thing that I want to do with this problem is I want to flip the whole fraction. If we flip the whole fraction, we end up with 3x squared over 4y to the 8th, and my outside exponent is now positive. And finally, my last step is to go ahead and distribute, in quotations, the cube to everything inside. So 3 cubed is 27. 4 cubed is 64. And then now remember that since we did the exponent to the number, I want to back off. I want to multiply my exponents. So we get x squared cubed is x to the 2 times 3, or 6. Y to the 8th cubed, we're going to multiply 8 times 3, and we get 24. And there is our final answer. All right, I'm only going to do that one way. If you want to try it another way to see if you come out with the same thing, that's fine as well. But that ends our discussion on negative exponents.